Hello friends, welcome back to our channel. In this video, we are going to discuss about IP address and MAC address. As part of this, we are going to discuss what is an IP address and what is a MAC address, what is the difference between them. We also would discuss about what are the different types of IP address based on the internet protocol version, the scope of the network, and based on the way of assigning corresponding IP addresses. We also would discuss about how these addresses are represented in terms of bits, ones and zeros, and we would discuss about the significance of this IP address and MAC address in networking. Let us start. IP address is Internet Protocol Address, which is part of network layer corresponding to OSI model. We have already discussed about OSI model in the previous video. Please go through the link in the description section if you want more information about different layers of OSI model. When we assign any device or a machine or a computer to a network, it will get an Internet Protocol address corresponding to network layer in the OSI model. So here in the diagram, we have various devices connected to the particular network. All these devices will be assigned a logical address which is called IP address. So this address is logical. That means it is not a fixed address. These IP addresses will be used for the communication between two hosts which are residing in the same network or in different networks. For example, this is a host 1 connected to particular network 1. So this is host 2 connected to a particular network N2. And if these networks are connected by different routers, so the communication between host 1 and host 2 will happen via corresponding IP addresses. So these IP addresses are logical. That means, for example, if a host is connected to a particular network, so this will be assigned an IP address IP1. If we disconnect the same device from network N1 and if we connect the same device to network N2, then this will be assigned a different IP address based on the IP addresses provided by this network. So that means the IP address assigned to a particular device is not a fixed address. It is a logical address that depends on corresponding IP addresses available on a particular network. Now let's discuss about IP address types. So we have different IP addresses based on the protocol version or the scope of the network and based on the assignment. So we have two types of protocols. There is Internet Protocol version with V4, which is also called as IPV4, and also we have Internet Protocol with version V6, which is also called as IPV6. So based on these protocol versions, we have different forms of IP addresses. For example, with IPV4, we have 32-bit IP address, and this is represented using decimal dot notation. That means we have 4 octets, 1, 2, 3, and 4, separated by corresponding dots. So each represents 8 bits, which is also called as octet. So in these 32 bits, we have the network part as well as host part. For example, if this is the IP address, so this can represent a network part and this can represent host part. We'll discuss about this when we discuss about subnetting. So we also have the protocol IPv6. So if the network provides IPv6 addresses, then each address will contain 128 bits, and this IP address will be represented in hexadecimal format. So this is an example of IPv6 address. So this IPv6 address is divided into 8 parts. Each contains 16 bits. So this 16 bits is represented in hexadecimal format. That means each indicates 4 bits. So 4, 4, 4. So total 16 bits. Here also we can divide that based on our requirement. Like this may represent network address or this may represent host address. That division would be done based on project requirements. Like this, we can have different IP addresses based on the protocol version IPv4 or IPv6. We can also divide the IP addresses based on the scope. That means the public IP address or private IP address. So public IP address means the IP address would be routable via internet. So if the IP address is routable via internet, it would be unique in the entire global network. We also have another type of addresses. The name indicates this is a private IP address. That means this IP address is private to a particular network, and these private addresses are not directly routable via internet. So this is about private and public IP addresses. The next classification is based on the assignment. If a device is connected to a particular network, we can assign the IP address manually. That means it is a static IP address. For example, for servers, we can assign these static IP addresses. We can also assign IP addresses automatically using a protocol called DHCP, which is Dynamic Host Configuration Protocol. So using this protocol, all the devices which are connected to a particular network will be assigned IP addresses automatically. In this way, we can have different types of IP addresses based on protocol version or the scope of the network or by the way of assignment. Now let us discuss about MAC address. MAC address is also known as Media Access Control Address. This address corresponds to data link layer in OSI model. So here, if we see, different devices are connected to a LAN. Each device will have a network interface card. This network interface card will have corresponding MAC address. This MAC address is assigned by the manufacturer of this network interface card. So this is a physical address and this is a fixed address corresponding to this device. So each MAC address is corresponding to a particular network interface card of that machine. This address is represented in hexadecimal format and each address is of total 48 bits or 6 bytes. Here this represents 8 bits. This represents 8. So total we have 6 octets, 6 into 8 bits, total 48 bits. So what is the use of this MAC address? So these MAC addresses will help the communication between devices which are connected to a particular local area network. So here each device will have corresponding MAC address. If one device wants to communicate with another device in the same LAN, then they will communicate via these MAC addresses. So how does one device knows the MAC address of another device? For that, there is a protocol called ARP, which is nothing but Address Resolution Protocol. So each device maintains ARP cache. So this cache will contain the mapping of the IP address with corresponding MAC address. For example, if this device wants to communicate with this device within the same LAN, then this device will send a broadcast packet to the entire LAN. So that packet will contain the destination IP address of this machine. So that packet which contains the destination IP address will be received by each of the devices, and then whatever device with corresponding IP address matches, that device will send the reply to the source machine with corresponding MAC address. The source device will update the ARP cache with corresponding MAC address of the destination IP. So once it updates, then it will use that MAC address for sending the data to the destination device. So this way, the ARP cache will be used by all the devices which are connected to a LAN to communicate with each other through their MAC addresses. So this ARP is valid for IPv4. For IPv6, there is another protocol called NDP, which is Neighbor Discovery Protocol. So this way, the MAC addresses are used by the devices which are connected to a local area network. So the difference between MAC address and IP address is the MAC address is a fixed address, but IP address is a logical address. And MAC address works in the layer 2 and IP address would be used in the layer 3. And MAC address would be useful within the local area network, and IP address would be useful for the data communication between the hosts in different networks. So let's summarize the IP address and MAC address formats. As discussed, the IPv4 address contains total 32 bits. So these 32 bits are divided into 4 octets and each octet contains 8 bits. Here each octet is represented in decimal format. So how to convert this decimal to binary? So for example, if we take 192, so we need to divide that number by 2 and we need to note down the remainder. So if we divide 192 by 2, the quotient is 96 and remainder is 0. And we need to continue this until we get the quotient as 0. So we need to continue here. So this is 48 and this is 0, 24, 0, 12, 0, 6, 0, 3, 0, 1, 1. So here 1 is a quotient and 1 is the remainder. So finally 0 is the quotient, 1 is the remainder. So we need to note down all these remainders like 1, 1, 0, 0, 0, 0, 0, 0. We are representing these 8 bits as 192 in decimal format. So similarly, other 3 octets will be represented in corresponding 24 bits. So this way, IPv4 address will be represented in dotted decimal format with 4 octets. Each octet contains 8 bits. So with 32 bits, we can have maximum of 2 power 32 IP addresses. This number will not be sufficient to represent all these devices. So that is the reason like we have a concept of public and private IP address. So these private IP addresses will be useful to reduce the requirement of number of public IP addresses by each of the organization. So what are the private IP address range we have? So we have different types of private IP address range. So this is one. So these are different ranges of IP addresses we can use in the private IP address space. So here 8 means this is the network prefix. So each IP address contains 2 parts, network part and host part. This network prefix will be used to represent how many bits are used to represent the network part in the IP address. For example, if we have 8 here, that means 8 number of bits are used to represent the network part. For example, here this is the network part and remaining 24 bits are used to represent different hosts. That means here we have 2 power 24 IP addresses which are represented corresponding hosts. Similarly here 12 bits are used to represent the network part. So we'll have 32 minus 12. So that means we can have total of 2 power 20 number of IP addresses to represent corresponding hosts in the network. Similarly here 16 bits are used to represent the network part. So remaining 16 bits will be used to represent corresponding hosts. So we'll have 2 power 16. So here we have used the example IP address ranges with network prefix 8, 12 and 16. So based on these network prefixes, we can have like different classes of IP addresses like class A, class B and class C. We'll go through them in the next video when we discuss about subnetting. So basically in those classes of IP addresses, the network prefix will be fixed to 8, 16 or 24. If you don't want to use the fixed network prefix, that means we can have dynamic value of this network prefix. In that case, we'll use CIDR, which is classless internet domain routing. In this, we'll not have a fixed network prefix. We'll discuss about the CIDR also in the next video. Similar to IPv4, we'll also have IPv6 addresses. So in IPv6, we'll have total 128 bits, which is divided into 8 groups, and each group contains 16 bits. So here, each of these group will represent corresponding hexadecimal number. For example, for 2001, if you want to represent in hexadecimal, this is 0010, 0000, 0000 and 0001. So this is 2, 0, 0 and 1. So this way we can represent all these 8 groups with corresponding binary numbers. With 128 bits, we'll have total of 2 power 128 IP addresses. So this number is very huge. So that means we can use this IPv6 addressing to represent all the devices in the global network. So this is the reason some companies are moving to IPv6 addressing, because each organization will have ample number of IP addresses to represent corresponding devices. So similar to IPv4 and IPv6 address, MAC addresses of the devices are also represented in terms of binary numbers. Here MAC address is represented with corresponding hexadecimal numbers. It is divided into 6 groups and each group contains 8 bits. So total we have 48 bits. So this is an example MAC address which is represented in corresponding hexadecimal notation. So this is about the formats of IPv4 and IPv6 address as well as MAC address. In this video we have gone through what is an IP address and what is a MAC address. We have also discussed what is the difference between them and how they are represented in different formats. We also discussed about different types of IP addresses based on the protocol version, based on the network scope, as well as assignment. In the next video, we are going to discuss about the subnetting as well as CIDR. I hope this video is useful. Thanks a lot for watching.